Why you gotta make it gay? Why you
gotta
make it
gay?
gay?
We're in chapter 32 and we're doing homework problems.
It's a little small, but we can work like that.
Oh, shit.
And we're starting with number 7. Calculate the cutoff frequency, the closed loop gain for the guy underneath. All right, so we'll go with the gain first because it's the simplest one. Gain, non-inverting amplifier, RF divided by RF plus 1. So RF1 over RF2, right? F.
RFL?
RF1, RF2. Or is it RF2, RF1?
Oh, it's RF1 over RF2.
Yeah, that's what I thought. So 15K, 30K, plus 1, 1.5. So the closed loop gain of the non-inverting amplifier that's sitting there will be 1.5, which isn't much of a gain. That's fine. Now we want to find the cutoff frequency, RC. And I think it's probably 1 over square root of R1, R2, C1, C2. But I will look in the book. There might be a pi thrown in, and so we'll have to go look and find out. Looks like we're on page. Yeah, there we are.
You'll find me a jump in the air. Need more of those searchers. They get free flight. No, I don't think so, not anymore.
Okay, so it looks like we're. No, don't like that one either. I found it. Page 890. 809. So on page 809, I need a 2 pi thrown in.
2 pi.
Yeah. What does 2 pi do for us? 2 pi or not 2 pi? Not 2 pi, that's the question.
2 pi?
Yeah. 2 pi or not 2 pi? That's the question. Should we take the remedial math classes or not? So that's the issue. The issue is the difference between, what if I have 1 hertz, then I have 2 pi radians per second. So basically, I want my frequency to be in hertz. So if I divide by 2 pi, I basically am changing something that's that one way, and I'm changing into a hertz thing. So that's basically a conversion of units that's going on there. All right, so back to what we're doing, because what is the time constant, right? RC. So R times RC times C. This becomes the time constant. So I have 2 pi seconds, and or I have seconds down here. If I change it to 2 pi seconds, then I end up with frequency when I divide. Okay, so that's the name of that term. So now we got to put it on a calculator. 1 over 2 pi square root of, where's the problem? 10K, 10K, 1 nano, 2.2 nano. So that's what we're doing. And maybe my calculator will do that if I power it up. 1 divided by pi. Oh, I didn't put parentheses in. 1 divided by parentheses pi times square root. Okay, 10 double E3. 10 double E3 1 double E minus 9 times 2.2 double E minus 9. Syntax error, darn. There we go. Cut off. 21460 hertz. I'd probably call, how many significant digits do you think we have? All of one? So we have all of one significant digit. I'd probably call it 20 hertz, 20 kilohertz. But there'd be nothing wrong with 21 kilohertz. That'd be perfectly okay too. All right, well, that's all there is to that one. 11. All right, now I have something that's looks like I have some type of bandpass filter. I want to find the cutoff frequency 1, the cutoff frequency 2, square root of 30K, 15 pico, and what's the 30 pico? 30 pico, and then the second cutoff frequency 1 over 2 pi square root of 10K, 20K, $100 pico. No. Yes. 100 pico, 100 pico. And then I'd ask myself, yeah, I've got one lousy significant digit, so that's all I'm going to do. Okay, 2 times pi 1 over 1 over parentheses. I didn't put a 2 in that last calculation, did I? Did anybody else run that last calculation through their calculator?
The first one?
Yeah.
Yeah, I come up with,
Because I don't, my calculator doesn't show a 2, so I'm going to have to divide this answer by 2.
I got 10,730.
Yeah. 10.7K?
Yeah.
Okay, that looks like a better number.
Okay.
Yeah.
Well, that makes more sense because I was wondering what the hell I did wrong.
No, that's a good thing about this new calculator. I can see what I've entered after I push the enter button.
These TI-36s?
Yeah.
Yeah, that's what I like about them.
Yeah, that's good. So yeah, that was not right. All right, so we'll try this guy. 2 times pi. I'm so excited about not having to hit second function pi to get it that I forgot to put the 2 in. Square root. Let's see, 30 double E3, 30 double E3, 15 double E minus 12, 30 double E minus 12. Looks like I'm at 250 kilohertz. Okay, second guy. 1 divided by 2 times pi times square root of 10K, 20K, 100 pico, times 100 pico. Syntax error.
You do C3, you do the case.
Stupid thing.
Is it 12 or 9?
9 is
9 is
the-
9.
Yeah. I got 250.
Is that right?
Yeah, you got 2
Syntax error.
now. That one up.
You want 12?
No.
Syntax. You know? It's behind. Picos.
It's just really,
How come you got it?
that's what I like about my C3. And then put
Okay, I've got 113. 100 and, I'll call it 112. 112 kilohertz. Okay, so I got C1 and I got C2. Now I want to find the bandwidth. So bandwidth, FC1 minus FC2. 140, 138K. Then I want to find the geometric center of the frequency. So, geometric center of the frequency. Who made this up anyway? Okay, so that's going to be the square root of FC1 times FC2. All right, so I can handle that. Square root of 250 times 112 we'll call it 167. 167K. And then we want to know the Q. Do we want to know the Q? Yeah, we want to know the Q. So that's F0 divided by the bandwidth. 167K, 138K, 1 point something. 1.21. We'll call it 1.21. Why not? Am I done? We're done. That's all I wanted. 11. That was 11. 21. I hope they get harder.
Yeah, it's said in that chapter.
The next chapter's easier?
No, I said in the chapter.
21. Calculate F1, F2, okay, so we're going to do the same thing over again. Okay, so CF1, CF2, 1 over 2 pi RC, 1 over 2 pi RC, I think. I don't think we have to do a square root this time. Which problem am I doing anyway? 21?
Yeah. You're doing number 21.
No, I'm not.
Well, that's what you're
I
supposed
was
to
doing number 20.
Why were you doing that?
I don't know, because no one called me on it. Now I got to erase everything because that's problem number 20. Yeah, what's wrong with the front row anyway? Calculate the operating frequency for the circuit shown below. The operating frequency, huh? So I want some circuit with two. Oh, this is a oscillator guy. So let's see if we can find an oscillator with two diodes in it. There we go. I see it. Page 826. On page 826. And I see that the frequency is going to be 1 over 2 pi RC. Okay, isn't that wonderful? And as long as R1 is equal to R2 and C1 is equal to C2. Alright, so I'm looking at this guy. Is R1 and R2 the same? Yes. And C1 and C2 are the same. Alright, so 1 over 2 pi 33k times 22 pico. We'll call it 220k. Now we'll call it 219k. No, we can't do that. We only have two significant digits. Okay, we'll call it 220k kilohertz as our final answer. Is that all there is? There ain't no more? All right, 25. All right, now things will get easier because we don't have to look at pictures and we only have words. Okay, you ready?
Yes.
1001, 1002. Was that enough?
Well, you gotta scroll down a little bit.
Oh, you want me to go to it, scroll down for a second, and a second is a euphemism for as long as it takes. Okay, gotcha.
Yeah.
Right.
Yeah, you're good.
Not literally in the sense.
You're good, sir. Thank
All right,
you.
I'm okay now?
God is going to bless you with a bunch of kids.
Well, let's hope so. All right, 25. The circuit shown on the previous page, which I can't see. All right, so there's a circuit on the previous page I can't see. C1 is 10 nanofarads. C2 is 1 microfarad. Boy, that was a really shitty micro. L1 is 3.3 millihenry. Calculate
Is that an L?
alpha V and AV. Where? This guy over here?
Second one.
This one here? That's an L.
Okay.
L1. Yeah. All right.
Sir.
So now I got to turn it over to the other page. Okay, so I'm looking at what appears to be probably a coal pits type thing. Okay, so we go and find that circuit.
No, it's no.
Okay, I see it. I see it on page 829. All right. So alpha V is going to be C1 divided by C2, and AV is going to be approximately C2 divided by C1. And I'm getting that from page 830. Okay, well, I think I can probably do that. 10 nano divided by 1 micro, 0.001. 1 micro divided by 10 nano, 100. I think the decimal point goes there, though, doesn't it? All right. So now we'll use our calculator. 10 nano divided by 1 micro. Yeah, that's correct. And if I go 1 over the answer, I get 100. Okay, good. You do know the, let's move down a little bit. So this is the TI-36 Pro guy. You had a 1 over key on your other calculator, on the TI-36. Well, this guy also has a 1 over key. Looks like that. So if you have an answer and you push that key, that second function second function the key that looks like this.
Yep.
Yeah, and so if you have an answer in your calculator already, or a number in your calculator, and you use this guy, that's the same as using that guy. So 5, second function, 1 over equals 1/5, because I have it in math type and not numbers. All right. All right, so we do have a 1 over key on that calculator if you haven't found it yet. 35. Am I done with the one I'm working? Yeah, I am. Okay. So once I get done with 35, then we can go home. Number 35. Some of you can. Some of you have other things to do. The feedback inductor illustrated in 2358 is shown to have a variable inductor. Yes, I see that. Determine the adjustment of L that should be required for the operating frequency of that. So the operating frequency we want is 22 kilohertz. And we have this circuit over here, and I see it. Okay, so I'm going to move back. And do I have a circuit with a variable L in it? No, I don't. But this circuit is on page 829. So I'm looking at page 829, and I see that F sub R is 1 over 2 pi square root of L times the total capacitance, and the total capacitance is C1, C2 divided by C1 plus C2. Okay, so we come back to our original problem. Total capacitance is going to be 100 nanofarads, 10 nanofarads divided by 110 nanofarads. Okay, so that's 1,000. So 1,000 divided by 110, and I get 9.09 nanofarads. The operating frequency we have and we want is 22K. So 22K is equal to that goes that way, right? 1 over 2 pi, 1 over 2 pi square root of L, 9.09 nanofarads. Okay, I'm going to cross multiply 22K, 2 pi square root of L, 9.09 nanofarads is equal to 1. And then I'm going to square both sides. 22K squared times 4 times pi squared times 9.09 nanofarads times L is equal to 1. And then I'm going to say L is equal to 1 divided by 4 pi squared 22K squared 9.09 nanofarads. And now I'm ready to use my calculator. 1 divided by 4 times pi squared times 22K squared times 9.09 double E minus 9. Close parentheses equals, syntax error again, I don't have a parentheses after my divide sign. Luckily I can just put one in. Second function, insert a parentheses. Boom. So L is going to be 6 millihenry. Okay, questions about that? Okay, so why did I do all those unnecessary steps in the math problem?
Because you wanted us to stay here longer?
Yes, I want you to do the same thing when you're solving problems for a net. I want you to use more paper and come up with the correct answer instead of using less paper and coming up with some BS that she has to give you partial credit for while she's holding her nose. Okay,
Damn.
so
I don't know where you're going with this.
that's the purpose.
That's amazing.